Hi, I'm Popadon42, and this is my Minecraft computer. It's not anything special at the moment, it's pretty buggy, and it doesn't do much, but it works. This project was inspired by the Little Man computer made by Peter Higginson. I remember playing around with it, and do you know that thought you get when you look at something in real life and think, I can build that in Minecraft? Yeah. I've seen other people make computers in Minecraft, so I'm not the first to do this, and I would highly recommend you check out LegoMaster99's video on his computer, linked in the description. Now, let's check out the specs of this computer. This bad boy has a whopping 16 bytes of RAM and has a 4-bit single-core CPU with a clock speed of about 0.125 Hz. It has memory reading and writing capabilities, and it's even programmable. It adds, it subtracts, it even stops. Only 7.5 bytes of RAM actually used. Computer still in progress. Success on executing code may vary. Ts&Cs apply. Now, let's get into what this computer can actually do. It's all in this book in the map here. If you want to read it, pause the video on whatever page. Okay, so now that you know everything about this computer, let's do a quick test with what this computer can do. But before we do that, we need to learn some basic computer science. This computer is currently being programmed in an assembly, so each line of code here is only one line of machine code. Each line uses a piece of concrete powder. Each block is an instruction and has an instruction code. When the line is executed, the code for that instruction goes into the instruction register and is decoded here to be executed. All instructions except END have some sort of additional input. These are put into the address register to be used. The accumulator is where data accumulates, and the program counter is currently useless. And all of these lamps over here are RAM. Now, before I show you some examples of what this computer can do, we actually need to understand what's happening in the examples, and to do that, we'll need to understand some basic binary addition. Regular numbers are base 10 because there are 10 numbers from 0 all the way to 9. When you reach 9, you run out of original numbers and you just steal the first 2 to give you 10. With binary, it's base 2, so there's only 0 and 1 to deal with. You've reached 1 and run out of numbers. 1, 0. This in base 10 is 2, and then we keep adding 1. Look, and now we've got 4. And now this is 8. Are you seeing a pattern here? It's doubling the numbers every time we add a new digit. If you got that correct, you don't win anything because it's really not that hard to spot. The way we can find base 10 numbers from binary is by adding these columns. For example, we have 1, 0, 0, 1. If we add those columns, we get 9. Now that you understand binary conversion, let's look at some examples of how the computer works. We have the number 1001, which we just figured out is 9. Let's say I wanted to take away 3 and replace it. Well, we can use this code here. There's a lot to unpack here, so let's unpack it together. First, we input 0011, since that's 3 in binary, and we store it in the RAM address 1110. Then, since we're taking 3 from 9, we need to load 9 into the accumulator, which is stored at address 1100. Then we subtract 3, which we stored in 1110. Then we store the new number into the original number's address, 1100. Let's take a look at it running, and you can see the tables above for reference. And there we have it, a successful subtraction. We finally ended up with the number 0110. Now let's find out what that number is. It's 6. We successfully took 3 from 9. Now to show you this can actually add too, we've got a simple addition bit of code here. And there we have it, the original 1001 number in the accumulator there. That's my Minecraft computer so far. Updates will be made soon and hopefully slightly more polished. The link to the map is in the description if you want to check it out for yourself, and just go and have yourself a nice day.